KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
Free bus for LKG to 8th standard.
Free, hygienic and nutritious food.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Education Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
In continuation to the last class, in this class we are going to discuss next fourth exercise problem, right? So yesterday we discussed 3 exercise problems, so it is fourth problem. See here, so this is the class of Ray Optics Numericals 2, Ray Optics second class for numericals. So now we are going to discuss next continuation of exercise problems. So first problem is fourth problem, it is the fourth exercise problem. First I will explain you the problem, then we will go for solution. See here. So if you see this problem, here there are 3 pictures or figures, right? A, B, C. See here. So figures A, B shows refraction of an incident ray. Figures A, B show refraction of an incident ray, right, in air at 60 degrees, right? Air at 60 degrees with the normal. You know very well, when we are going to measure the angle of incident ray or angle of refracted ray, we took normal as a reference to measure, right? So it is the normal, here it is the normal, right? It is the incident ray, it is the refracted ray, it is air, it is glass. So here it is air, it is water. Here the ray is coming from air to water, right? But here the ray is going from air to glass, right? So anyhow, here that is what the incident ray is present in air medium in figure A. In figure B also the incident ray is present in air medium, right? But the medium to what, the medium for what the ray is going will be different. So here it is glass, here it will be water, right? That is, okay. See here. So figure AB show refraction of an incident ray in air at 60 degrees with a normal to a glass air. This is what a glass air and water air. Here also angle of incidence is 60 degrees, that you have to keep in mind. So angle of incidence here is 60 degrees, here also 60 degrees. It is glass air interface, it is water air interface, right? So refraction of an incident ray in air at 60 degrees with a normal to a glass air and water air interface respectively, right? Predict the angle of refraction of an incident ray. Predict the angle of refraction of an incident ray in water at 45 degrees with a normal to a water glass interface in figure C. So it is the figure C. It is water glass interface. It is the water glass interface. It is the 45 degrees is here angle of incidence and this is the angle of refraction. So this angle of refraction we have to find. That is the question, right? So to find this angle of refraction, they have given some data in figure A and figure B. By using this data and by using the concept of refraction and mostly Snell's law here, that is what second law of refraction. So you know the laws of refraction. The first law of refraction is incident ray, refracted ray, normal must lie in the same plane. Second law of refraction is the ratio of sine of angle of incidence to the sine of angle of refraction is constant. The ratio of sine of angle of incidence to the sine of angle of refraction is constant, right? So that is also called as Snell's law, right, which is second law of refraction, okay, right. Now we are going to see the solution clearly. Observe carefully. This is the figure A. So here I told you what is the incident ray. So this is the light. So this is the incident ray. This is what refracted ray. It is angle of incidence. It is angle of refraction. It is air medium. It is glass medium. So the light ray is passing from air medium to glass medium. The light ray is passing from air medium to glass medium, right? So that is important because to find the refractive index, that is the light ray is going from what optical medium to the next optical medium is important, right? Otherwise the situation will be different. So here, based on this figure, that is what figure A, we can write A mu G. A means air, mu means the notation to represent the refractive index, and G is the glass. So A mu G is equal to sin I by sin R, sin I by sin R, right? So here I is 60 degrees, R is 35 degrees, sin 60 degrees by sin 35 degrees, okay, right. Sin 60 degrees by sin 35 degrees, okay ma. So the value of sin 60 degrees is equal to here, that is what 0.8660, and here sin 35 degrees is equal to 0.5736, that is equal to 1.51, right? So it is a mathematical thing. So the concept means this is how we are writing this relation is physics concept. Afterwards just we are substituting the values, that is what 60 degrees in place of I and 35 degrees in place of R. So sin 60 degrees by sin 35 degrees is equal to 0.8660 divided by 0.5736, that is equal to 1.51, okay, that is right. So A mu G, that is what refractive index of this is what ma. So you keep in mind what are the two media, that is what are the pair of media, what are the two different mediums. So here one is air, another one is glass. So that is very important for us regarding this problem and regarding these problems related, that is whatever it may be, okay. So here A mu G is equal to 1.51, okay, right. Now same procedure we are going to apply for figure B. See here A mu W is equal to sin I by sin R, same formula, that is second law of refraction, that is Snell's law. Mu is equal to sin I by sin R, right. So here 60 degrees is I and R is the 41 degrees, right. So sin 60 degrees by sin 41 degrees is equal to 0.8660 is the value of sin 60 degrees and 0.6561 is the value of sin 41 degrees, right. That is equal to 1.32, right. So A mu W is equal to 1.32 and in from figure A mu G is equal to 1.51, okay, right. Now from figure C, same procedure we applied. Just you observe here W mu G, the light is coming from water medium and entering into, that is what, glass medium. At the point of separation of both the media, it bends, right, it bends away from the normal, right. See here, this is what it is what glass, no, here it is the glass, right. So when it is glass, see this, it is water, see here W mu G is equal to, you can write this one, no, you just see here ma, W mu G you can write as A mu G by A mu W, right, A mu G by A mu W, right. That is also equal to sin I by sin R, no, right. So this you know, that is what W mu G is equal to sin I by sin R, you know, but the same W mu G, that is what water, this is what glass, this ratio you can also write like this, that is what A mu G by A mu W. In this equation or in this expression we are going to substitute the values, that is what we got from figure A and figure B, right? So from figure A it will be 1.51 and figure B it will be 1.32, right? So 1.51 by 1.32 is equal to, see it is what, the 45 degrees, no? Sine 45 degrees to sine R. So it is R. So the unknown thing what he is asking to find is R. Generally angle of refraction we used to represent by using the English letter small r. So here also the same thing we are doing, right? So it is sine r, and the value of sine 45 degrees is 0.7071, right? And 1.51 by 1.32 is equal to 0.7071 by sine r, okay, right? So finally sine r is equal to, right? So what is sine r? See this, sine r is equal to, you can write now, see this, these two things. Actually if you cross multiplied sine r into 1.51 is equal to 1.32 into 0.7071, right? So then what about sine r? Sine r is equal to 1.32 into 0.7071 divided by 1.51, that is equal to 0.6181. So it's a mathematical calculation, right? Here multiplication, and this product of multiplication of these two numbers is going to divide to this 1.51, and then it will give us 0.6181. Then sine r is equal to 0.6181 means what about small r? It is the sine inverse, no? Small r is equal to sine inverse of 0.6181. Small r is equal to sine inverse of 0.6181. It will give you 38.2 degrees. 38.2 degrees. This is the final answer we can calculate based on the given question. That is what here he is asking now. Predict the angle of refraction of an instant ray in water at 45 degrees with a normal to a water glass interface in figure C, right? So that is what 38.2 degrees approximately, okay, right? So in this problem they have given two pictures, that is what figure A and figure B. Here they have given some data also, that is what angle of incidence and angle of refraction, and angle of incidence and angle of refraction. Based on this, based on these two pictures, and by applying the second law of refraction, that is mu is equal to sin I by sin R, right? So we calculated and we found what is A mu G and A mu W. A mu G is equal to 1.51, A mu W is equal to 1.32, right? And from these two things, next we are going to find, that is what W mu G. Meanwhile, so while finding the W mu G, that is what you can write A mu G by A mu W, right? So there itself, see, we cannot find this W mu G because R is unknown to us now. But our intention is not to find W mu G, our intention is to find R. So that's why procedure is same, whatever the procedure we followed here, the same, but in place of W mu G we are writing A mu G by A mu W, that is equal to sin I by sin R, and substituting the given values, finally you can find out R is approximately equal to 38.2 degrees, right? Next problem, that is problem number 5. So first I will read the problem, then I will go for solution. So you please be concentrate. See here, a small bulb is placed at the bottom of a tank containing water to a depth of 80 centimeters. Right? What is the area of the surface of water through which light from the bulb can emerge out? Light from the bulb can emerge out, right? So you please be concentrate here. So what he is asking is, what he is saying, first saying and then afterwards they will ask to find something, right? A small bulb is placed, you can see this picture, this is the place of the bulb. A small bulb is placed at the bottom of a tank containing water. So here we have water, containing water to a depth of 80 centimeters. So this is what 80 centimeters. So this is what 80 centimeters, okay, right? what is the area of the surface of water? This is actually this is the surface of water, but he is asking, if you concentrate you can understand, what is the area of the surface of water through which light from the bulb can emerge out, right? And meanwhile he also giving refractive index of water, that is 1.33, and then consider the bulb to be a point source, right? So when I was explaining in the same chapter, that is what ray optics, I told you what is the difference between point object or point source and extended object or extended source, right? So point source means like this red light. You are seeing one red light, no, there, laser light. So it is like point source. But the extended object means it will be like this, right? So it has some length. Extended object or extended source means, for example, I will tell you, tube light. You know, tube light, what is present in our classrooms. So tube light is the example of extended object. But you know, tungsten filament bulb, otherwise the zero bulb, right? So it is when we are using in bedrooms, right? So to give a small amount of light. So the zero bulb is like example of point source, but a tube light is the example of extended source, right? So keep in mind the difference between point source and extended source. But in this problem, our that is what we consider a point source, okay, right? So a small bulb is placed at the bottom of a tank containing water to a depth of 80 centimeters, right? What is the area of surface of water through which light from the bulb can emerge out? Light from the bulb can emerge out, right? So it is this area we have to find. This area we have to find, okay? A refractive index of water is 1.33. The refractive index of water is 1.33. Consider the bulb to be a point source, right? So here, so we have to consider the bulb to be a point source, right? Now see here, see the solution. The light rays from the small bulb S, which are incident at an angle I, is greater than IC. So it is what IC. First these two are the IC, so then it is also IC, right? So it is like a normal at this point, and this is also normal at this point. You know very well, angle of incidence is the angle between normal to the incident ray. So it is IC and this is also IC. Then automatically this is IC and this is also IC. That is what geometrical properties of triangles and here, right? So the geometrical properties of lines and triangles. Okay, right. So the light rays from the small bulb S, which are incident at an angle I is greater than IC, are total internally reflected and cannot emerge out of water surface, right? So in our, that is what in the same chapter ray optics, I explained you what is critical angle and what is total internal reflection, right? So here the phenomena is total internal reflection. You know very well, when angle of incidence is greater than the critical angle, the total light reflect back into the same medium and no light will go out of the medium, right? So that only he is saying here, totally internally reflected and cannot emerge out of water surface, right? Okay. The light from the bulb S comes out through a circular path of radius R given by, this is what? The light from the bulb S comes out through a circular path of radius R given by, right? Suppose for example a person is here, he is seeing the surface of water, means he can see that, he will see that this is the part of water surface, this is the part of water surface which is like illuminated. That is what like illuminated means, you know very well, no? That is what for example if you see this part of the water surface, it is like dark, okay? But if you see this part of the water, it is like glowing, like shining and like illuminating, right? So that is the difference between this part of the surface of water and this part of the surface of water and this part of the surface of water, right? And here you can see like ordinary water surface, but here it is what the water surface which is illuminating, right? He is asking what is the area of this spot? What is the area of this spot? Okay, that is the question, right? You know very well, tan theta, this is what I see now, it is like right angle triangle now, it is like right angle triangle, and this is the radius of the circular path, radius of the circular path, and this is h, you know very well, tan IC. So tan theta is equal to opposite side by adjacent side, opposite side by, right, opposite side by adjacent side. So here tan IC is equal to OA by OS, right. So OA is smaller and OS is small h. Then from this relation you can write R is equal to, that is what, small r is equal to small h into tan IC, small h into tan IC, okay, right. But at the same time, you know this relation, this is what, relation between critical angle and refractive index, relation between critical angle and refractive index, that is what, mu is equal to 1 by sin c formula is there, no. So sin c is equal to 1 by mu, and mu value already given, that is 1.33. So 1 by 1.33 means that you can write it as 3 by 4, right. It is what, 3 by 4, that is sin IC is equal to 1 by 1.33 means that you can write it as 3 by 4. If you know the sin IC, then you can find out cos IC, because you know very well sin square IC plus cos square IC is equal to 1. Sin square theta plus cos square theta is equal to 1. So then what about cos theta? Like that, here cos IC is equal to square root of 1 minus sin square IC. So this is the result, that is cos IC is equal to square root of 7 by 4, square root of 7 by 4, right. Okay. So if you know these two things, that is what, sin IC and cos IC, then you can find out tan IC, that is what, sin by cos, tan IC is equal to sin IC by cos IC, that will be 3 by root 7, 3 by root 7, right. So we got what is sin IC and what is cos IC and what is tan IC, right. Now see here, area of the patch, so this is called as patch, that is what, a circular, that is what, the circle, the circular path, that is what, illuminated by the light, the circular path illuminated by the light. Circular path means we should not see only the circumference, total circle, that is what, area, the total area is going to covered or illuminated because of this bulb, small bulb S, okay, right. So area of the patch is equal to pi r square, area of the patch is equal to, you know very well, the area of the circle, the formula is pi r square, right. And pi is, okay, it's, you know, 3.14, but r is equal to h tan IC, no. But here square is there now, so that h square tan square IC, and h means already, you know, that is what, 80 centimeters, 80 centimeters means you can write 0.80 meters, right. Square is there, and tan IC is equal to 3 by root 7 now. So tan square IC means 9 by 7, tan square IC means 9 by 7, okay, that is equal to 2.58 meter square, 2.58 meter square. This is what, area of the patch, area of the patch, okay, that is equal to 2.6 meter square. 2.58 means rounding off. So in units and measurement chapter in the first year syllabus, we got what is rounding off. If the last digit is greater than 5, the preceding digit is raised by 1. So 2.58 is approximately equal to 2.6 meter square, okay, right. So in this problem they have given one situation, that is what, a water tank, that is a small water tank, and here he kept a bulb. He is asking to find what is the area on surface of water illuminated due to this light, okay. So that we found by using that formula, that is what, mu is equal to 1 by sin c, mu is equal to 1 by sin c, and as usual the formula of area is pi r square, right. So based on these two things, we came to conclude, that is what, area of the patch is 2.6 meter square, right. Next problem, sixth, that is problem number 6, see here, first I will read the problem, then we will go for solution, okay, right. See this, a prism is made of glass of unknown refractive index, a prism is made of glass of unknown refractive index, full stop. A parallel beam of light is incident on a face of prism, on a face of prism, full stop. the angle of minimum deviation is measured to be 40 degrees, right? What is the refractive index of the material of the prism? What is the refractive index of the material of the prism? Full stop. I mean question mark, that we have to find. Next, the refracting angle of prism is 60 degrees. So that is the given thing. If the prism is placed in water, predict the new angle of minimum deviation of a parallel beam of light. Okay. So in this question, right, two things we have to find. In case 1, that is what in the first half of the problem we have to find refractive index. In the second half of the problem we have to find new angle of minimum deviation, because we are going to change the medium now. See here, when we are going to change the medium where the prism is present, there the angle of minimum deviation will be changed. Then automatically that he is asking to find, right? So first half the problem he is asking to find the refractive index, and second half part of the problem he is asking to find new angle of minimum deviation when the prism is kept in water medium. Okay, right. So I will repeat once again the problem, you just focus now. A prism is made of glass of unknown refractive index. A parallel beam of light is incident on a face of prism. Full stop. The angle of minimum deviation is measured to be 40 degrees, right? The angle of minimum deviation is measured to be 40 degrees. What is the refractive index of the material of the prism, right? And that we have to find. Next, the refracting angle of prism is 60 degrees. It is like what the given thing, that is what angle of prism. Next, if the prism is placed in water of refractive index 1.33, then predict the new angle of minimum deviation of a parallel beam of light. Okay, so that we have to find. Two things we have to find, right? So first you write the given things. When the prism is placed in air, delta M is 40 degrees and A is equal to 60 degrees, right? And you know the formula for refractive index of the prism material, that is A mu G is equal to sin A plus delta M by 2 by sin A by 2, right? So this is the formula for refractive index of a prism in terms of angle of prism and angle of minimum deviation, okay? That is what sin 60 degrees plus 40 degrees by 2, this is what this they have given as 60 degrees now, and delta M is equal to 40, right? 60 plus 40 by 2 divided by sin 60 degrees by 2, that is equal to sin 50 degrees by sin 30 degrees. Sin, it is what 60 plus 40 is 100 now, 100 by 2 is equal to 50 now, that is what, right? Next here 60 by 2 is equal to 30 degrees, right? Sin 50 degrees is equal to 0.7660, right? Sin 30 is equal to 0.500, you know very well, sin 30 is equal to 1 by 2, that is equal to 0.5000, right? So it will be 1.532. If you do this division mathematically, it will give you 1.532, right? So the refractive index of the material of the prism, that is what refractive index of the prism material is 1.532, okay, right. Next, when the prism is placed in water, the formula is same, but here it will become mu, it is W, before it is A now it is W. Prism is same, it is made up of glass, there is no change. Prism we didn't change, only we are changing the medium where the prism is present, okay. So here W mu G is equal to sin, the formula is same, that is what sin A plus delta M dash, because when we change the medium where the prism is present, the angle of minimum deviation will change now. So that here we put delta M dash. So sin A plus delta M dash by 2 by sin A by 2, right? So if you substitute the things what they have given, that is what refracting angle of prism, that is what angle of prism 60, and this side, that is what left hand side, in place of W mu G you can write A mu G by A mu W, right? And what is A mu G here? That is what 1.532, right? And this value already given, it is 1.33. So 1.532 by 1.33 is equal to sin 60 plus delta M dash by 2 by sin 30 degrees. And the cross multiplication. Otherwise, you just take this sine 30 to this side, then it will multiply the whole of this. This is what this part with 1 by 2. Then sine 60 plus delta m dash by 2 is equal to 1.532 by 1.33 into 1 by 2, right? So this is what 30 plus delta m dash by 2, right? 30 plus delta m dash by 2 here, that is what, okay, here sine, this is what after completion of this step, here if you do this mathematically, you will get it as 0.5759. It's okay. Afterwards, if you do this, that is what 30 plus delta m dash by 2, 60 by 2 means 30, no, 30 plus delta m dash by 2 is equal to, so if you take the sine to that side, sine inverse of this value 0.5759 will give you 35 degrees 10, that is what 35 degrees 10 minutes, 35 degrees 10 minutes. But you take this 30 to that side, then what will happen? It is 5 degrees 10 minutes because it is 30 degrees, no. So if you subtract this 30 from this, 5 degrees 10 minutes will come, but it is delta m dash by 2, no. But he is asking to find new angle of minimum deviation, that is what delta m dash. So because of that, so 5 degrees 10 minutes into 2, so it is 10 degrees 20 minutes. So new angle of minimum deviation is 10 degrees 20 minutes. Okay. So in this problem, first we found refractive index and then we found new angle of minimum deviation when the prism kept in another medium, that is water. Okay, right. So in this class we discussed about these three exercise problem. We will continue in the next class. Thank you.